This question is from 2003 AP Physics B, and now these topics are covered in AP Physics 2. So let's look at this FRQ. The question states that a circuit containing two resistors, 10 ohm and 20 ohm, and two capacitors, 12 microfarad and 6 microfarad, connected to a 6-volt battery, as shown in the diagram above. The circuit has been connected for a long time. When they say such words as circuit has been connected for a long time, that means the capacitors are fully charged. Calculate the total capacitance of the circuit. So when you calculate the total capacitance of the circuit, you see that these capacitors are connected on the same line. So they are connected in series. When capacitors are connected in series, to find the total capacitance, you have 1 over plus 1 over the result flip over. So what that means is I have 1 over the capacitance of the first one, so that's 12. And I'm going to ignore the microfarad for now because at the end, my result is going to be in microfarads. Plus 1 over, so I have 1 over 6. And I'm finding my result. So the common denominator is 12. And I'm going to times by 2 the top and the bottom of the second fraction. So that will give me, the numerator is equal to 3. So I have 1 over, the result flip over. So my result has to be flipped over. And I have 4, and my result is in microfarads. So the actual formula is 1 over the capacitance of the first capacitor plus 1 over the capacitance of the second capacitor. And what you get is the 1 over the resultant capacitor, or the total capacitance, or the sum of the capacitors. So this symbol, like an E sign, means the sum of them. And I noticed that my students are doing well when we know the formula, but we also remember how to say it. So we're always saying 1 over, the result flip over. So we find the total capacitance by following these rules, and then when we flip the result, and I know that all my capacitance was in microfarad, so my answer is in microfarad. So calculate the total capacitance of the circuit, and in this case, it's going to be 4 microfarad. And sometimes instead of the symbol micro, you can see 4 U and then farad, because not all devices have micro sign. So instead of writing micro, they write U, because this part of the micro is missing. For the next question, they ask you to calculate the current in the 10 ohm resistor. So if the circuit has been on for a long time, that means the current only flows along the red line, because the capacitors act like an open switch when they are fully charged. So when there is no potential difference between point A and point B, the current is not going to be flowing through the capacitor because the capacitor is fully charged. So that means the point A matches the capacitance of the top capacitor plate, and then point B matches the charge on the bottom plate of the capacitor, 6 microfarad. So there's going to be no current flowing through the capacitors. So if I want to calculate the current through 10 ohm resistor, I have the EMF of the battery, or the voltage of the battery, divided by the total resistance of the circuit. And because both resistors are connected in series, we just add them, so 10 and 20. So that's going to be our total resistance. So the current through 10 ohm resistor is equal to 6 volt divided by 10 plus 20, which is 30. And that will give me 1/5, or 0.2 amps. For the next question, they ask you to calculate the potential difference between point A and B. So if you calculate the potential difference between point A and B, it's the same potential difference as the potential difference or the voltage dropped on 20 ohm resistor. So this voltage V is going to be equal to the current through that resistor times the resistance of that resistor. So that voltage is equal to the current is the same all through the red line through that circuit, so which is 0.2, we just calculated it, and the resistance on that resistor is 20, so the voltage on that resistor is 4 volts. So for C, the answer is going to be 4 volts. And the total voltage dropped on each resistor should be equal to the voltage of the battery. So the voltage dropped on the top resistor, 10 ohm resistor, is going to be the current through it, which is 0.2, times the resistance on it, which is 10. So the voltage dropped on that one is 2 volts. And the total voltage of one dropped on 10 ohm resistor and one dropped on 20 ohm resistor together should give you the total voltage that you have leaving from the battery. For the next question, they ask you to calculate the charge stored on the plate of 6 microfarad capacitor. And what I look at when I look through the capacitors is that the charge is the same as the current in the series circuit. So if you have a battery and you have a resistor and a resistor, then the current through this circuit is going to be the same. So what I call it is it measured in amps. So the current is measured in amps. I call them little aliens. So there are many different aliens running through the circuit. And if there was an observer, I'm going to place an I. And if there was an observer watching those little charges or currents running through each room, we call this like a room or a bridge, then they will observe exactly the same current or charges. So when it comes to the capacitors, we treat the charge on the capacitors the same as if we treat the current in the circuit. So the capacitors must have the same charge on them for the current not to flow through them. So if I want to calculate how much charge is on each capacitor, and it's the same one, I can calculate how much charge total on both of them. So what I'm going to do is to use the capacitance formula. So the capacitance formula says that it is how much charge stored per voltage. And I know the voltage between A and B we calculated earlier is 4 volts. And I know the total capacitance. The total capacitance is 4 microfarad. So I have 4 micro means 10 to the negative 6. The voltage between A and B is 4. And here is the charge. So the charge on either one of those capacitors is going to be 16 micro and measured in coulombs. So that is 16 microcoulombs. And then for the next part of the question, they ask you, so if the wire is cut at point P, so if this wire is cut at point P, that's where the point P is, the shaded gray area, will the potential difference between point A and B increase, decrease, or remain the same? Because the current was not flowing through between point A and B through the capacitors, that means there is already disconnection between point A and B. So the only current was floating is the current that was going through the resistor, 20 ohm resistor. So this part of the circuit was already disconnected, like if it was cut. So that means cutting a wire at P will not change the potential difference between A and B, because the potential difference between A and B we calculated by using Ohm's law when we calculated the current through 20 ohm resistor times the resistance of the 20 ohm resistor. So cutting the wire at point P does not change the potential difference between point A and B. And that is all that I have for this question from 2003 AP Physics B. And thank you for watching. Subscribe if you like it, and I hope I will see you in my next videos.